The universe unfolds in silence. Galaxies drift like ancient lanterns across a black ocean, their stars bound in spirals too vast for any single mind to comprehend. Black holes tear at the fabric of space-time, swallowing light itself. Supernova erupt with the force of billions of suns, scattering elements across the void. And yet, in the midst of this violence, an uncanny harmony persists. The cosmos does not fall into disorder. It dances, with precision, to an invisible rhythm. Every particle, every orbit, every flicker of starlight moves according to rules no one can see, yet all must obey. Planets circle stars, not in chaos, but in orbits written by geometry. Light bends around gravity in arcs foretold by equations. Even the decay of atoms, random in appearance, unfolds within the boundaries of probability. The universe appears not free, but bound, its every act scripted by something deeper than matter itself. But what are these laws? They are not etched in stone, nor whispered by any voice. They have no author we can point to, no origin we can touch. They exist as abstractions, yet they hold galaxies in their grip. Humanity calls them laws of nature, but whether they are discovered truths or invented descriptions remains uncertain. Are they eternal principles, older than time itself, or fragile agreements that last only as long as this cosmos does? Long before telescopes pierced the night, before equations etched themselves into paper, there was wonder. The ancients gazed upward and saw not chaos, but rhythm. Stars returned to their places with exquisite regularity. The moon cycled with unbroken certainty. The seasons shifted in patterns, as if the heavens themselves breathed. To early minds, the sky was not a wilderness, but a hidden geometry waiting to be understood. In Greece, the word cosmos was born, meaning not just the universe, but order itself. The philosopher Pythagoras whispered of harmony, believing that the heavens resonated like the strings of a lyre, each planet a note in the grand music of existence. Plato imagined celestial spheres turning in eternal perfection, their motions driven by invisible balance. To them, the universe was not free, but guided by principles beyond sight. Mathematics became the first language of these hidden patterns. Euclid inscribed the rules of geometry. Archimedes bent numbers to describe balance and motion. Aristotle wove his vision of a structured cosmos where every object sought its natural place. Their models were flawed, but they shared one profound conviction that nature was intelligible, that its workings could be captured by reason. The idea of law, not written by kings, but woven into the fabric of reality, began to take form. Civilizations beyond Greece also turned to the skies, not for philosophy alone, but for survival. The Egyptians raised monuments aligned with solstices, their calendars born from the Nile's rhythm. Babylonian astronomers traced the paths of Venus and Jupiter, predicting eclipses centuries before modern science. To navigate seas or plant crops, one had to trust that the heavens would not betray their order. Laws of nature were not abstractions then. They were lifelines. Centuries passed. The earth remained fixed in human imagination until a Polish canon, Copernicus, dared to move the sun to the center. Galileo, with glass lenses and stubborn defiance, revealed mountains on the moon and moons orbiting Jupiter, evidence that the heavens were not immutable perfection, but governed by consistent mechanics. Then came Kepler, wrestling with the orbit of Mars, who found that planets did not wander arbitrarily, but traced ellipses, their motions described by elegant mathematical rules. Kepler's laws were more than astronomy. They were humanity's first glimpse of the universe as a system obedient to principles that could be written down, tested, and trusted. No longer myth, no longer divine whim, but numbers and curves, laws that did not bend. The transition was profound. For the first time, nature was not seen as an unpredictable stage of gods and spirits, but as a vast, ordered structure, where events unfolded according to principles that existed whether one believed in them or not. In this moment, the concept of laws of nature was born, fragile but unshakable, and the question began to take root. Why does the universe choose to obey? The transformation from myth to measurement did not happen overnight. For millennia, humanity balanced between two visions of the cosmos, one of divine will, where gods moved the heavens, and one of order, where rules shaped motion. Even as philosophers speculated on hidden harmonies, temples and priests still read the sky for omens. Yet slowly a shift took root. Each observation of a star's return, each careful mapping of a lunar eclipse, whispered the same truth, that the cosmos was not chaos, but consistency. And consistency demanded explanation. Among the first to shape that explanation was Pythagoras, who saw in numbers a sacred key. To him, reality itself was built on ratios, harmonies, and patterns that echoed both in music and in the heavens. The idea that planets themselves moved like notes upon a scale was not science in the modern sense, yet it carried a profound intuition that mathematics was not just a human invention, but a window into the structure of the universe. From this seed, a tradition began, the belief that behind the shifting appearances of the world lay something permanent, something law-like. Plato extended this vision, teaching that beyond the imperfect and changeable world lay eternal forms, unbroken and pure. The stars and planets, to him, were the most faithful reflections of this perfection. He imagined them mounted on crystalline spheres, their rotations eternal and exact. Though this model was flawed, it reinforced an enduring conviction. The heavens were not subject to chaos, but to a hidden symmetry. Aristotle refined the picture into a systematic universe, with Earth at the center, each object seeking its proper place. Though centuries later his physics would be overturned, the framework carried one revolutionary idea forward, that nature itself was lawful, comprehensible, and structured. But outside the halls of philosophy, laws of the heavens had a different meaning. For farmers along the Nile, the regular rising of Sirius foretold the flooding that sustained their crops. In Babylon, astronomers traced planetary cycles, predicting celestial events with startling accuracy. These patterns were not curiosities, but anchors of survival. Navigation across seas, the timing of harvests, the planning of empires, all relied on trust that the sky would not deceive. Even without understanding the deeper causes, civilizations built calendars, charts, and monuments aligned with the rhythms of the cosmos. The universe obeyed rules, and humanity, knowingly or not, leaned upon them. Then came the slow turning of a greater revolution. For centuries, the earth had been regarded as unmoving, the fixed point around which the cosmos turned. But Copernicus dared to challenge this certainty, placing the sun at the center of motion. His heliocentric model shattered more than astronomy. It redefined humanity's place in existence. The earth was not privileged, not unique, but part of a system bound by shared principles. Reality, it seemed, did not bend for humankind. Galileo followed, lifting a simple telescope to the sky. What he saw was not a realm of divine perfection, but a world of scars and shadows. The moon was pocked with craters and mountains. Jupiter was surrounded by its own moons, worlds in miniature orbiting a greater world. These discoveries were evidence that celestial bodies obeyed the same principles as Earth, dissolving the old barrier between heaven and nature. Yet it was Johannes Kepler who gave these revelations their most enduring form. Through tireless calculation, through failures and revisions, he uncovered the laws of planetary motion. Planets did not move in circles, as tradition had demanded, but in ellipses, their speeds changing as they swung round the sun. His laws were not guesses, not myths, but mathematical truths, predictive and exact. The heavens were no longer a mystery veiled in myth, but a system of order written in numbers. Here the idea of laws of nature crystallized. They were not decrees of gods, nor abstractions of philosophers, but measurable, repeatable, universal. And yet, even as they revealed themselves, they opened a deeper. If the universe followed such rules with perfect fidelity, what compelled it to do so? Were these laws inherent to existence, or were they shadows of something greater, something not yet known? The 17th century brought with it a moment of profound revelation. In the quiet pages of the Philosophiae Naturalis Principia Mathematica, Isaac Newton carved a framework that would bind the heavens and the earth in a single vision. With 3 laws of motion and the universal law of gravitation, he declared that the same principles guiding an apple's fall also governed the orbit of the moon. No longer was the cosmos divided between terrestrial and celestial realms. All motion, from the smallest pebble to the largest planet, obeyed the same mathematical command. For the first time, reality appeared as a totality governed by law. The universe, once the stage of mystery and myth, revealed itself as a grand equation unfolding with a precision so exact it seemed mechanical. The motions of comets, the tides of oceans, the arc of a cannonball, all were written in the same language. Newton's laws did more than describe nature. They suggested inevitability. If one knew the position and velocity of every particle, the future itself could be calculated, as certain as the ticking of a clock. This vision carried with it both awe and unease. For philosophers of the Enlightenment, the world became a machine, a vast clockwork, its gears of matter turning with relentless necessity. Every event, every cause, every effect, bound together in an intricate web of determinism. Nothing arbitrary, nothing lawless. To many, this was liberation. The universe was intelligible, its secrets laid bare to reason. Humanity had been given the keys to predict, to master, to understand. Yet beneath the triumph, shadows remained. If the universe was so perfectly ordered, what role was left for chance, for freedom, for the unpredictable spark of life? Theological debates swelled. Some argued that Newton's God was a divine clockmaker who had set the laws at the beginning, and stepped away, leaving the machine to run on its own. Others believed these laws were not independent truths but decrees sustained by divine will, renewed at every moment by the breath of the Creator. Science and faith found themselves entangled in a new tension. Were the laws eternal principles of nature, or were they commands written by a higher power? The imagery of the clockwork universe spread beyond science. To live within a lawful cosmos was to realize that fate might be calculable, that chance might be an illusion. The falling of a leaf, the crash of a wave, even the beating of a heart, each motion could in principle be traced back through an unbroken chain of causes. It was a vision at once comforting and suffocating. Comforting because it suggested that nature would never betray its order. Suffocating because it left little room for spontaneity, Still, not all accepted this iron cage of determinism. Doubts lingered at the edges. Could every phenomenon truly be explained by law? What of turbulence, the chaotic motion of fluids, the unpredictable flicker of fire? Even in Newton's own equations, complexity often overwhelmed calculation, hinting that while the rules were there, the patterns they produced could be wild and seemingly unknowable. The clockwork metaphor, though powerful, concealed a deeper truth, that lawful systems could still generate profound unpredictability. Yet in the centuries that followed, Newton's vision shaped not only science but human imagination. The cosmos was no longer a battlefield of gods and forces beyond comprehension. It was a lawful domain, vast yet rational, governed by principles that applied everywhere to everything. A worldview had begun to crystallize. Nature was not arbitrary, not whimsical, not chaotic at its core. It was bound by law. The revelation left a lingering question that has not faded with time. If the universe is law-governed, why should it be so? Why must matter obey equations? Why does reality not wander into chaos, but remain tethered to principles that can be written down, predicted, and trusted? The mystery deepened, the more order was uncovered, the more pressing the question became of what compels the universe to follow rules at all. The Principia was not simply a book of equations. It was a declaration that reality itself could be written in human symbols. Newton revealed that the universe was not a chaos of events, but a system of predictable motions, unfolding as though guided by unseen machinery. The planets no longer drifted as wandering stars, their paths mysterious and divine. They became bodies bound to the sun by gravity's invisible tether, each orbit calculable, each return expected. The same mathematics that could describe an apple falling from a tree could also predict the turning of the heavens. For the first time, the human mind stood on the brink of comprehending not just fragments of nature, but the whole. The philosophical shock of this revelation cannot be overstated. If the universe was lawful, then it was also intelligible. The ancient hope that nature might be knowable had found its proof. Two philosophers of the Enlightenment, Newton's vision seemed to strip away the last veil of mystery. Reality was not arbitrary. It was structured, coherent, governed by equations that spoke with the authority of inevitability. From this flowed the metaphor that would dominate centuries of thought, the clockwork universe. The cosmos was a vast mechanism, its parts moving with perfect precision, as though wound by a master clockmaker at the beginning of time. Yet this metaphor carried unsettling implications. If every event followed from the last with mechanical necessity, what room was left for freedom, for chance, for the unpredictable spark of human will? Some thinkers found comfort in the image of a God who had set the laws in motion, sustaining them through divine order. Others saw in Newton's framework a universe that required no constant divine intervention, a self-sufficient machine running endlessly without oversight. The debate blurred the lines between science and theology, raising questions as profound as they were unsettling. Were laws eternal truths woven into the fabric of reality, or were they decrees enforced by something greater, unseen, beyond? Even within science itself, doubts remained. The elegance of Newton's equations could not erase the stubborn complexity of the world. The orbits of three or more interacting bodies defied simple solutions, dissolving into patterns so tangled they seemed chaotic. The swirling motion of fluids, the erratic flicker of flames, the turbulence of storms. These phenomena seemed to stretch the very laws that sought to contain them. Newton's framework had revealed that laws existed, but it also hinted that the universe might conceal layers of unpredictability within those laws, patterns that escaped even the sharpest calculation. Still, the triumph of Newtonian order endured. Ships crossed oceans with greater certainty, guided by mathematics. Engineers built machines that harnessed the predictability of force and motion. Astronomers predicted the return of comets centuries into the future. Every success reinforced the belief that nature was not capricious but law-bound. Humanity found itself in a universe where mystery was giving way to measurement, and uncertainty to certainty. But beneath this growing confidence, the same haunting question persisted. Why should there be laws at all? Why should the planets move as equations dictate? Why should gravity exist as a universal principle rather than a chaos of unpredictable forces? Newton himself offered no final answer. He described the laws, he demonstrated their reach, but he did not explain why the universe must obey them. That enigma lingered, untouched, waiting for later generations to confront it. Under the flickering glow of oil lamps and the clatter of early laboratories, a new kind of science began to emerge. The age of speculation gave way to an era of experiment, where nature would no longer be asked for answers in philosophy alone, but compelled to speak through observation. Robert Boyle bent over glass vessels and sealed chambers, measuring the invisible breath of gases. He found patterns in the compressions of air, rules in what once seemed fleeting and ungraspable. Each experiment revealed that, hidden beneath the chaos of the senses, lay a rhythm, a repeatable order that could be written in numbers. The natural world was no longer only a theatre of appearances. It was becoming a text to be deciphered. As centuries turned, the torch passed to Michael Faraday, a man of humble beginnings yet gifted with a vision of unseen forces. In his experiments with wires and coils, sparks and currents, he uncovered the profound interplay of electricity and magnetism. What once seemed separate phenomena revealed themselves as threads of the same tapestry, entwined in ways no human eye could see. Faraday spoke of lines of force stretching invisibly through space, fields that shaped matter as surely as the pull of gravity. To some, his ideas seemed mystical, more poetry than science, yet they hinted at a reality where the universe was woven not only of matter and motion, but of fields and energies, continuous and infinite. It was James Clerk Maxwell who would gather these insights and bind them into a single, elegant framework. His equations, four in number yet vast in consequence, gave form to the invisible. Electricity and magnetism were no longer separate mysteries, but facets of one deeper truth, the electromagnetic field. From them emerged the astonishing realization that light itself was an electromagnetic wave, racing through space at a constant speed. Suddenly, illumination, the very phenomenon by which humans saw the universe, was revealed as a vibration of fields that reached across the void. What had seemed ordinary was elevated into the cosmic. Light was no longer a divine symbol. It was a measurable pulse of the universe itself. The discovery reshaped the human sense of law. It was not simply that phenomena followed patterns, but that different domains of reality could be united under one principle: the fall of a stone, the flow of current, the propagation of light. Each belonged to the same order, different verses in the same universal song. The laws of nature began to appear not as scattered rules, but as converging harmonies, suggesting that behind the multitude of forces lay an underlying unity, a single fabric on which all events were embroidered. Yet even in this age of triumph, shadows remained. The instruments that expanded human sight, telescopes that revealed new worlds, laboratories that measured finer scales, also uncovered anomalies that defied Newton's perfect certainty. The orbit of Mercury, traced with meticulous care, betrayed a subtle deviation that Newtonian gravity could not explain. The most precise measurements whispered of deeper rules still hidden, forces not yet imagined. The cosmos, it seemed, offered its secrets reluctantly, yielding order but hinting always at greater mysteries beyond. In this tension, humanity stood at a threshold. Newton's laws had once seemed final, a complete description of a mechanical universe, but the experiments of Boyle, the visions of Faraday, the equations of Maxwell, and the stubborn irregularities of the planets all suggested otherwise. The universe was law-bound, yes, but the laws themselves might not be ultimate. They might be provisional, glimpses of deeper symmetries yet unseen. And so the question deepened. Were these laws eternal truths written into the fabric of reality since time began? Or were they stepping stones, temporary guides pointing toward an order more profound than any yet conceived? The 19th century closed with the sense that certainty itself was fragile, that even the most elegant equations might one day be replaced. Humanity had discovered the existence of laws, but had also learned to suspect that the story of law was far from complete. The pursuit of understanding the invisible forces of nature demanded not only intellect but imagination. Lines of force, invisible threads weaving through space, suggested that reality itself was alive with structure beyond immediate perception. To trace them, he built crude instruments, delicate coils and magnets, and observed phenomena that could not be touched or seen in ordinary ways. Each spark that leaped between electrodes, each trembling of a wire, was a whisper from the hidden architecture of the cosmos. It was an architecture that demanded patience, persistence, and a willingness to see what the senses could not. Faraday, lacking formal mathematical training, relied on intuition as much as measurement, revealing that the laws of nature were as much discovered by feeling and imagination as by calculation. Maxwell's genius lay in transforming these intuitions into formal mathematical truth. His equations showed that electricity and magnetism were not separate, that their union created waves propagating across the cosmos, waves whose speed was identical to that of light. In one elegant framework, light itself became a phenomenon of law, a pulse of energy moving through invisible fields. The implications were staggering. The universe was suffused with patterns of unseen forces, acting in concert, obeying principles far beyond the immediacy of human perception. Every beam of sunlight, every flicker of aurora borealis, every electric current coursing through the earth was evidence of this deeper coherence. Yet even as these discoveries revealed harmony, they also exposed the universe's resistance to complete comprehension. Observations of Mercury's orbit hinted at subtle deviations from Newtonian prediction. Precise experiments with electricity and magnetism suggested complexities that defied simple explanation. Humans were confronted with a paradox. Lawfulness existed, undeniable and elegant, yet within it lay hints of irregularity, of phenomena that could not be fully predicted. The universe was generous in its order, yet elusive in its completeness, revealing patterns only to draw attention to the mysteries still concealed. The instruments themselves became extensions of human perception, bridging the gulf between the tangible and the theoretical. Telescopes reached farther into the void than any eye could see, revealing moons and planets moving with precise rhythm, but also anomalies that challenged understanding. Laboratory apparatuses allowed the capture and measurement of currents, forces, and waves, translating invisible phenomena into comprehensible data. Through them, humans glimpsed the universality of law, a language that transcended culture, geography, and time, but also the limits of comprehension. The subtle fractures in what once seemed absolute, in this interplay of discovery and uncertainty, the notion of law began to evolve. It was no longer merely a descriptive tool, a set of rules for predicting motion. It became a window into a cosmos that was at once coherent and enigmatic. The universe revealed that order and mystery are inseparable. Laws guide reality, yet they do so within a framework whose deeper origin remains veiled. Humanity sensed that Newton's clockwork vision was incomplete, that the universe might obey principles far subtler, far stranger than any mind had yet conceived. The certainty of the visible gave way to the humility of the unseen, and the thrill of exploration became intertwined with the haunting awareness of limits. Even in these early investigations, a philosophical reflection emerged. Laws are not only discovered, they are felt, intuited, and, in some sense, lived. They define the boundary between chaos and stability, between what can be predicted and what remains forever uncertain. The universe, in obeying them, offered both a guide and a question. Why must it follow these rules? Each experiment, each observation, each calculation brought humans closer to the laws, yet paradoxically deeper into the enigma of their origin. The more the cosmos revealed itself, the more apparent it became that the ultimate question, the reason for order itself, was still unanswered, waiting for the next generation of minds to seek, to measure, and to imagine. The early 20th century carried the world of physics into an age of profound upheaval, where the very foundations of law were challenged and reshaped. Albert Einstein, with a clarity born of vision and intuition, reimagined the cosmos in ways that unsettled centuries of certainty. His theory of relativity revealed that space and time were not immutable stages upon which the universe performed, but dynamic participants in the unfolding of reality. Gravity was no longer a force acting at a distance, but a curvature in the fabric of space-time itself, a subtle warping that guided the motion of stars and planets with elegant inevitability. The laws of nature, once considered rigid, now flexed. In concert with the geometry of existence, the revelation was disorienting. What had been thought eternal and fixed, the tick of a universal clock, the unchanging backdrop of space, was instead a malleable tapestry, bending and stretching, yielding yet still obedient to a hidden consistency. The universe did not abandon law. Rather, law itself had become dynamic, intimate with the very stage it governed. Planets, light, even time itself moved according to principles that were local, relative, intertwined with the observer and the observed. To witness this was to feel both awe and disquiet, to recognize that the cosmos had rules, yet those rules were stranger, more fluid than imagination had allowed. At the same time, another revolution unfolded at scales far smaller than planets and stars. Quantum mechanics emerged, revealing that the fabric of reality was not deterministic, but probabilistic. The double-slit experiment illuminated a world where electrons and photons, particles of matter and light, behaved as both waves and particles, their paths undecided until observed. Here, obedience to law took on a curious, almost paradoxical character. Matter followed rules that defied classical intuition, rules that allowed probabilities, uncertainties, and paradoxes to govern behavior. The universe seemed less a clockwork machine than a dice thrower, each event constrained yet unpredictable, following patterns only in aggregate. Physicists such as Werner Heisenberg, Erwin Schrödinger, and Niels Bohr confronted these unsettling truths with rigor and imagination. Heisenberg articulated the limits of certainty, showing that one could never know simultaneously the precise position and momentum of a particle. Schrödinger envisioned the paradox of a cat, both alive and dead, a metaphor for the strange coexistence of possibility and law. Bohr's principle of complementarity suggested that reality could never be fully described in singular terms, that wave and particle, observer and observed, were intertwined. These breakthroughs revealed that laws did not dictate a single path, but a spectrum of potentialities, all bound by the structure of the quantum framework. Human emotion mirrored this cosmic ambiguity. The universe, it seemed, obeyed rules, yet those rules allowed freedom in ways classical physics could not predict. Awe mingled with fear. The certainty of Newtonian mechanics had been replaced by probabilistic obedience, a dance between order and chance, law and uncertainty. The cosmos became a game of hidden codes, a grand pattern where every outcome was constrained yet inherently indeterminate. In this world, obedience was no longer absolute. It was measured in likelihoods, tendencies, and the subtle interplay of potentialities. And yet, through this radical shift, a quiet truth endured. The universe, in all its strangeness, was still bound. Even the wild oscillations of quantum uncertainty and the curvature of space-time were governed by patterns, by constraints that could be understood, if only partially. The cosmos remained a text to be read, a music to be heard, an intricate design, obeying rules whose form had expanded beyond human intuition. It was a universe at once free and disciplined, chaotic and law-bound, a dice thrower with invisible hands, each roll determined not by whim, but by a deeper hidden code that continued to elude and enchant the mind. As the 20th century unfolded, the implications of these breakthroughs began to ripple across every corner of physics. Einstein's relativity had already dismantled the notion of absolute space and time, revealing that the universe itself was a living fabric, warped and stretched by mass and energy. Yet quantum mechanics showed that the very building blocks of matter were not rigidly determined, but probabilistic, dancing to a rhythm dictated by chance as much as law. The cosmos, it seemed, obeyed rules that were precise in some ways, fluid in others, duality that challenged not just intuition, but the very definition of what it meant for the universe to follow laws. The double-slit experiment epitomized this strangeness. Electrons fired at a screen produced an interference pattern only if unobserved, as if each particle knew of its surroundings and chose its path according to probabilities rather than certainty. Observation itself altered reality, revealing that law in the quantum realm was entwined with consciousness, measurement, and context. Reality was no longer an objective stage on which events unfolded. It became a participatory performance where the universe obeyed rules, not absolutely, but in subtle, conditional ways. The elegance of Maxwell's unifying equations now seemed almost naive in comparison to simpler harmony within a deeper, more enigmatic order. Physicists wrestled with these revelations. Heisenberg's uncertainty principle forced a rethinking of predictability, while Schrödinger's famous thought experiment with the cat crystallized the eerie paradoxes at the heart of the microscopic world. Bohr's complementarity suggested that dualities particle and wave Cause and effect could not be fully reconciled within classical intuition. These ideas unsettled the philosophical grounding of science itself. If law was probabilistic, if observation influenced outcome, what did obedience truly mean? The universe was still constrained, yes, yet its obedience was no longer absolute. It was contextual, emergent, woven from rules that allowed freedom within bounds. Humanity felt both awe and disquiet at this revelation. The deterministic clockwork of Newton and Kepler had offered reassurance. Reality could, in principle, be fully known. Now the cosmos appeared more like a vast game of chance, rolling dice according to hidden codes, its outcomes constrained yet uncertain, governed by probabilities instead of absolutes. Time could stretch and compress, gravity could bend light, and matter could exist in superpositions of states, all while following rules that defied immediate comprehension. The elegance of law had become subtler, stranger, yet no less realer, dynamic obedience that demanded both humility and wonder from those who sought to understand it. In this new view, the universe was both law-bound and free, orderly and unpredictable, a paradoxical masterpiece of constraint and possibility. The notion of universal law expanded. It was no longer merely a mechanical prescription, a fixed set of equations imposed from without. Instead, law became a living dialogue, a structure, within which uncertainty itself had its place, a tapestry where predictability and chance intertwined. And yet, in all this complexity, the fundamental mystery endured. If the cosmos could obey laws even in this probabilistic, relativistic, and counterintuitive way, what was it that compelled obedience in the first place? The question grew sharper, more urgent, hinting at a deeper truth still beyond human reach. A code written into existence that humanity could sense but not fully decipher. As the 20th century unfolded and science reached ever deeper into the fabric of reality, a more profound question emerged, one that transcended equations and experiments. Are the laws of the universe eternal, written into existence before time itself, or did they arise with the birth of the cosmos, born alongside the first moments of the Big Bang? The universe, once thought to be governed by immutable principles, now appeared more like a living manuscript, its rules emerging, evolving, perhaps contingent upon the conditions of its creation. Cosmologists began to wonder whether constants, long considered sacrosanct, the speed of light, the fine structure constant, the ratios of fundamental forces, might themselves be mutable, shifting imperceptibly across space or through eons of cosmic time. Each possibility shook the very foundation of lawfulness, suggesting that the universe's obedience might be provisional, not absolute. This uncertainty became more palpable when considering the extreme environments where known laws begin to falter within the crushing gravity of black holes. Space and time warp beyond comprehension. At the Planck scale, the very notion of continuity dissolves into quantum foam, a churning sea where familiar physics loses its foothold. Here, the rules themselves seem to fray, hinting that law is not universal but contextual, dependent on the stage upon which it operates. Constants that govern everyday phenomena may be merely local scripts, reliable under ordinary conditions, but failing when reality is pushed to its outermost limits. In this light, law appears less as eternal decree and more as an emergent scaffold, a temporary architecture that allows the cosmos to function without collapsing into chaos. Philosophers and physicists, have long considered the anthropic principle as a possible lens through which to understand this peculiar stability. Perhaps the laws we observe are not universal truths, but necessary preconditions for our existence. Only in a universe where gravity, electromagnetism, and quantum rules maintain a delicate balance could observers arise to ask the question. In other words, the apparent permanence of law may be an illusion, a reflection of selective survivorship. We see order because life itself is bound to emerge only in lawful conditions. The universe might host countless realms where law is different, inconsistent, or even non-existent, but we could never inhabit them, nor perceive them. Yet even this sobering insight does not diminish the beauty of law, it deepens it. Like the stage of a grand cosmic play, the rules may exist only for the duration of the performance. Singularity points, the throats of black holes, the instant of creation itself. These are moments where scaffolding might collapse, where familiar order dissolves into chaos, where laws bend or vanish entirely. Reality, then, is both fragile and resilient, fleeting and eternal, a tapestry held together by principles that work because they must. At least, long enough for matter and energy, life and consciousness, to emerge and perceive them. Human reflection grows quieter here, tinged with humility and awe. Law may not be a divine edict or an immutable truth. It may instead be an intricate choreography, an emergent pattern arising from the conditions of existence. The universe obeys, but obedience may be conditional, contextual, fleeting. Each particle, each photon, each ripple in space-time follows its rules as if performing a dance, aware only of the steps allowed, oblivious to the stage itself. In this vision, the cosmos is alive with order and uncertainty alike, a reality in which the rules hold, yet are never absolute, a play in which the performance is temporary, and the script may change with each act, and yet, amid these profound uncertainties, one certainty remains. The universe continues to obey, even as its obedience raises the most haunting of questions. Why must it follow any rules at all? What is the source of law, if not eternal decree? If constants shift, if singularities shatter certainty, then law itself is revealed as a mystery, more intricate and sublime than any human imagination can fully encompass. It is this enigma, the persistent, almost defiant order of reality, that beckons the mind forward, inviting wonder, reflection, and the quiet recognition that law is both real and incomprehensible, a bridge between the known and the unknowable. The more scientists probed, the more the cosmos revealed its subtle ambivalence. Observations of the early universe suggested that the very fabric of reality was not fixed in every respect. Tiny fluctuations in the cosmic microwave background hinted at a universe that began orderly, yet seeded with randomness, where the large-scale structure of galaxies emerged from delicate instabilities. Even the constants of nature, assumed immutable for centuries, were now suspected of a gentle malleability. Could the speed of light or the strength of electromagnetism differ elsewhere, or have changed over eons? Each possibility expanded the mystery. If law itself is contingent, then the universe is less a rigid machine and more a living experiment, where patterns emerge because they can, not because they must. Black holes offered a further provocation. At their cores, space and time collapse into singularities, points where curvature becomes infinite and known laws dissolve. General relativity predicts their existence, but it cannot describe what occurs within. Quantum mechanics governs the small, relativity the large, yet neither alone can fully grasp the extremes. Here, law may fray at its edges, revealing that what humans perceive as universal order may be only an approximation, reliable in most contexts, but incomplete at the boundaries of existence. These extremes suggest a universe that obeys, yet does so within constraints, obeying rules that may themselves be emergent, temporary, or local. Law is no longer absolute. It is conditional, an architecture that works for the cosmos as we know it, but not necessarily beyond it. The anthropic principle adds a haunting reflection to this mystery. Perhaps reality appears low-bound, precisely because only in such a universe could life and consciousness exist to ask the question. A multitude of possible universes might exist, each with its own conditions, its own constants, its own potential for chaos. Most of these universes would be barren, their laws incompatible with matter coalescing into stars, planets, or life. Our universe, by contrast, follows patterns finely tuned to allow existence. In this sense, law is both real and selective, a necessary condition for the observer, yet perhaps accidental on a cosmic scale. Humanity glimpses order not because it is guaranteed, but because life itself is bound to arise in ordered realms, and yet, even amid this conditionality, there is beauty and subtle reassurance. The universe behaves as though it follows a script, even if that script is emergent rather than eternal. Reality may be a stage play where rules exist only while the performance lasts, yet for the duration of existence, the cosmos dances with coherence, precision, and elegance. Particles follow patterns, planets orbit predictably, light travels in waves, obedience endures, even as the foundations beneath it remain uncertain. Law becomes a living concept, flexible yet reliable, fragile yet enduring, a structure within which both matter and mind can emerge. Human reflection turns inward here, sensing the enormity of the question. Law may not be eternal, it may not be imposed, it may not be universal. It may be scaffolding, a temporary framework within which existence can unfold. And yet, the universe continues to obey, even as it hints at possibilities beyond comprehension, even as it reveals its own subtle fragility. The cosmos is law-bound, yet its obedience is enigmatic, provisional, and sublime, a profound dance between order and uncertainty, permanence and impermanence, the known and the unknowable. In this tension, the mystery deepens, and the question that has haunted humanity since the first observation of stars remains unanswered. Why must the universe obey rules at all? At the frontier of modern physics, the universe begins to blur, to bend, to shimmer in ways that defy conventional understanding. The twin pillars of relativity and quantum mechanics, each triumphant in its own domain, resist unification. One governs the vast sweep of stars and galaxies, the curvature of space-time and the dance of planets, while the other orchestrates the subatomic, the jittering particles, and ephemeral waves that underlie all matter. Yet the cosmos itself does not segregate scales. It is seamless. To understand the laws in their deepest essence, scientists must seek a framework where these disparate realms converge, where law is not compartmentalized but unified. This search has led to ideas as audacious as they are beautiful, revealing a universe that is at once precise and elusive. String theory proposes that all fundamental particles are not points, but tiny vibrating strings, each oscillation dictating the properties of matter and energy. The diversity of phenomena, from electrons to photons to quarks, emerges from variations in vibration like notes in a cosmic symphony. In this vision, laws are not rigid prescriptions, but patterns arising from the underlying music of the universe. Gravity, electromagnetism, and nuclear forces all become emergent harmonies of these strings, suggesting that the universe obeys rules not because they are fundamental, but because the vibrations themselves produce coherence. Every particle, every force is a manifestation of deeper rhythm, and the laws we perceive are the surface melody of a profound hidden orchestra. Meanwhile, loop quantum gravity offers a complementary yet radically different perspective. Instead of continuous space-time, it suggests that the fabric of reality is granular, composed of discrete quanta of space and time. The smooth continuum described by relativity emerges from this underlying lattice, and laws arise as statistical patterns, emergent rather than absolute. Gravity itself may be not a fundamental force, but a product of this deeper network, obeying patterns that emerge from the scaffolding of discrete space-time. Here, law is no longer imposed. It is born from structure, a natural consequence of the cosmic architecture itself. These ideas converge on a haunting possibility that law is emergent, not fundamental. In extreme conditions, singularities at the Planck scale, or within hypothetical other universes, different rules may hold, and the apparent universality of law may be only a local phenomenon. Multiverse theories suggest countless realms, each with its own constants, its own physical behaviors, some potentially hostile to matter or life as we know it. What humans perceive as immutable law may be contingent, a pattern that arises because only certain configurations of reality permit stable structure. The emergence of galaxies, stars, and conscious observers. Law may be a reflection of necessity, not decree, a pattern arising from deeper chaos rather than a universal script. Some physicists have even framed the cosmos as a kind of cosmic code, a program running on the substrate of existence. Are the laws we observe lines of computation embedded in reality, algorithms that govern the evolution of the universe? Is the universe obeying a hidden logic, one that can be read but never fully written, a code whose author remains unknown? In this metaphor, law is neither eternal nor imposed. It is emergent, functional, and constrained by the architecture of the cosmos itself. And yet, for all our ingenuity, human knowledge remains finite. Instruments, telescopes, particle accelerators, and thought experiments push ever closer to the horizon, yet there is always a veil. Singularities, the first instant of the Big Bang. The Planck scale, these are regions where theory falters, where equations break down, and where law itself may dissolve into unknowable reality. The extreme edge of science is both thrilling and humbling. We can glimpse patterns, hint at unification, imagine the music of the strings, the lattice of space-time, the multiverse beyond. Yet the ultimate source of law remains concealed. Obedience is evident, yet its origin is not. The universe continues to follow rules that are at once elegant, emergent, and mysterious, and humanity stands at the precipice, peering into a realm where the very concept of law may itself be only a shadow of a deeper, hidden truth at the extreme edge of understanding. The universe becomes a place of paradox, where familiar rules give way to possibilities that strain comprehension. In the heart of black holes, where gravity curves space into near-infinite distortion, and at the first moments of the Big Bang, the distinction between law and chaos blurs. Known equations collapse. Time and space themselves are no longer continuous, backdrops but turbulent actors in a drama beyond human intuition. Here, the universe obeys patterns that may be fleeting, emergent, or conditional constraints that hold only because the underlying substrate allows them. Reality, it seems, is both disciplined and unruly, a structure arising from the interplay of profound simplicity and infinite complexity, the unifying ambitions of string theory, which imagine the cosmos as a vast orchestra of vibrating strings, carry both promise and uncertainty. Each string's oscillation dictates the behavior of matter and energy, and yet the sheer number of possible configurations is staggering. The laws we observe may be but one melody among a cosmic symphony of possibilities, a composition selected from an almost infinite set of potential harmonies. If this is true, then the rules themselves are emergent patterns, stable only in configurations where complexity can persist. The universe is law-bound, yet the source of that binding is not external decree but the intrinsic possibilities encoded in the vibrations, themselves a code written into existence before our comprehension, revealing order where once there seemed only chance. Loop quantum gravity offers a different, equally profound vision. Space-time, it suggests, is composed of discrete quanta, a lattice from which the smooth continuum of relativity emerges. Laws, in this picture, are not imposed. They are statistical patterns arising from the underlying network. Gravity, motion, and even causality may be emergent features, consequences of a deeper structure that remains largely invisible. The obedience of the universe is thus a property of this architecture. The cosmos behaves predictably, not because law is eternal, but because structure generates regularity. It is a subtle, almost poetic inversion of human expectation. Law is not the root of reality, is the flower that blooms from it. Multiverse theories push this contemplation further, suggesting countless universes with different constants, different rules, different possibilities altogether. Some may be sterile voids, others may be realms where light bends differently, where matter cannot coalesce, where life is impossible. Our laws appear fixed only because we inhabit a cosmos where stability allows existence. Law becomes a selective phenomenon, a reflection of survivorship on a cosmic scale. Even the constants we hold sacred may vary elsewhere or elsewhere in time, revealing that obedience is conditional, local, and emergent rather than absolute. And yet, amid this vast complexity, the universe still follows patterns that can be discerned. The cosmic code metaphor imagines the universe as a program running on the substrate of existence, obeying algorithms too vast and subtle for direct observation. Instruments push the boundaries, probing black holes, colliding particles at near light speeds, peering back to the earliest photons, yet the ultimate source of law remains hidden behind a veil. Obedience is evident in the dance of galaxies, the propagation of light, the coherence of quantum fields. Yet its origin remains enigmatic, a mystery entwined with the very act of existence itself. Reality is law-bound, yet law is emergent, fragile, and infinitely deeper paradox that defines the extreme edge of science, where every answer deepens. At the heart of modern physics lies the Standard Model, an intricate framework that codifies the fundamental particles and forces shaping the universe. Quarks and leptons, bosons and photons, each obey precise rules that govern interactions with astonishing fidelity. Electrons orbit nuclei, quarks bind to form protons and neutrons, And the strong and weak nuclear forces choreograph subatomic behavior with a rhythm that has been confirmed in laboratories across the world. The Standard Model is a triumph of human insight, a map of the unseen, revealing that beneath apparent chaos lies order of extraordinary subtlety. It is the grammar of matter, a syntax written in mathematical language, binding reality together from the smallest scales to the very stars. At cosmic scales, Einstein's theory of relativity still reigns supreme. Space-time bends and warps galaxies, rotate like curves around massive clusters, all as predicted by a century-old framework. Gravity, once Newton's simple attraction, is now understood as the geometry of space itself, guiding the flow of celestial bodies with elegance and precision. The success of relativity is a reminder that even as physics probes the quantum, the universe maintains coherence at grand scales. Laws operate consistently across immense distances and epochs, a testament to the robustness of nature's code. Even when its deeper origins remain mysterious, physicists have long sought unification, dreaming of grand unified theories that combine forces into a single, elegant principle. The electro-weak unification, which merges electromagnetic and weak nuclear forces, offers a glimpse of this possibility, a tantalizing demonstration that disparate laws may emerge from a single underlying framework. Symmetry underpins this quest. Nature, it seems, favors balance and equivalence. Particles and forces are constrained by geometric patterns, by transformations that leave the essence unchanged. Emmy Noether revealed a profound connection between symmetry and conservation, showing that laws of energy, momentum, and charge flow naturally from deeper invariances. The universe obeys rules not arbitrarily, but because its structure is coherent at the most fundamental level. Yet mainstream physics remains humble. The Standard Model, elegant as it is recognized as incomplete. It cannot fully account for gravity in the quantum realm, for dark matter, or for dark energy that accelerates cosmic expansion. The laws observed may be approximations, edges, of a deeper geometry whose contours we can glimpse but not yet fully trace. Even within the most precise equations, there is mysterious suggestion that law is emergent. A shadow of more profound principles, a visible trace of an unseen architecture that shapes reality. In this light, the cosmos appears simultaneously ordered and enigmatic, a tapestry whose visible threads are laws, and whose hidden weave may contain symmetries and structures far beyond human perception. The poetic vision is irresistible. The laws we discern are the edges of a deeper, invisible geometry, hints of a cosmic design whose full breadth remains inaccessible. Conservation, symmetry, and unification are not merely principles, they are the audible notes of the universe's hidden score, patterns that resonate across space and time, from quarks to quasars. Each experiment, each observation, each calculated prediction reaffirms that reality obeys law, yet every anomaly, every incompleteness reminds us that law is a guide, not a decree. Humanity glimpses order at the surface, perceiving rules as the contours of a more profound, unseen structure. And in this perception lies both knowledge and wonder, a humbling recognition that even our most powerful theories touch only the outer harmonies of an eternal cosmic song, even as the Standard Model and relativity provide a framework of extraordinary precision. Physics acknowledges that these laws may be provisional glimpses of something far more profound. They operate flawlessly within the realms humans can probe, yet cracks appear at the edgiest places, where dark matter exerts unseen influence, where dark energy drives the accelerated expansion of the cosmos, and where singularities threaten to dissolve the known rules entirely. These phenomena suggest that the laws we observe, while elegant and reliable, may be the visible surface of a deeper geometry, a shadow of patterns that extend beyond measurement, beyond comprehension. In this sense, the universe is both disciplined and mysterious, obeying rules that are tangible yet simultaneously veiled, hinting at a hidden architecture whose full nature remains elusive. Symmetry, at the heart of mainstream physics, illuminates this hidden order. Nature's preference for balance manifests across scales. Particles mirror each other in antiparticles. Forces unify under transformations, and conservation laws emerge as natural consequences of invariance. Noether's insight that every symmetry corresponds to a conserved quantity revealed that law itself may be a reflection of deeper mathematical harmony. Energy, momentum, electric charge, and more are not arbitrary prescriptions. They are consequences of the universe's intrinsic balance. Each equation, each principle, is a glimpse into this underlying structure, a testament to the coherence that pervades existence. Yet the elegance of symmetry coexists with the humility of recognition. These are not ultimate truths, but maps of the patterns observable from within our cosmic vantage point. Grand, unified theories provide a tantalizing vision of what may lie beyond. The successful unification of electromagnetic and weak nuclear forces suggests that what appear as separate laws may be manifestations of a single underlying principle. It implies that the universe is not a collection of disconnected rules, but a coherent system whose laws emerge from a deeper unity. In this light, the laws we observe are the visible edges of a vast hidden geometry, the tip of a cosmic iceberg whose bulk is yet to be found. Each particle collider, each astronomical observation, each precision measurement extends our reach into this hidden landscape, revealing both the elegance of law and the profound depth of mystery that surrounds it. And yet, the limitations of knowledge remain ever present. Mainstream physics accepts that even its most successful frameworks may be approximations, models that describe phenomena within certain scales and energies, but falter at extremes. Black holes, the Planck scale, and the earliest moments of the Big Bang are realms where these laws may break down, where known symmetries may not hold, and where reality itself could operate under rules beyond current comprehension. Humanity stands at the threshold, perceiving the patterns that govern existence, yet aware that these patterns may only hint at the deeper, unseen scaffolding beneath. The poetic reflection emerges naturally. The laws we discern are not ultimate decrees, but the outlines of a hidden geometry, resonating across space and time, offering guidance without revealing origin, order without disclosing cause. Even in their provisionality, the laws remain breathtakingly elegant. Conservation, symmetry, and unification are not just technical constructs, they are the audible notes of a cosmic melody, patterns that echo through the lattice of reality from quarks to galaxies. They provide a framework in which matter can coalesce, stars can ignite, and life can emerge, yet they also leave space for wonder, ambiguity, and philosophical reflection. Each law is a window into the sublime coherence of existence, a trace of a hidden design whose depths may never be fully known. The universe obeys, yet the obedience itself is layered with mystery. Law is visible, tangible, and measurable, but its ultimate source, why it exists, why it holds, why it structures reality at all, remains beyond reach. At the outermost reaches, of scientific speculation, the nature of law becomes not just mysterious, but almost surreal. Among the boldest ideas is the simulation hypothesis. The suggestion that the universe itself may be a programmed construct, a vast computational arena, in which laws operate as coded constraints. Gravity, electromagnetism, the behavior of subatomic particles, these may be rules embedded in the operating system of reality, imposed not by necessity, but by the architecture of a cosmic program. In this vision, the universe obeys law, not because of intrinsic properties, but because its foundational substrate has been designed to ensure coherence, stability, and continuity. The cosmos becomes a digital stage, and physics a set of programmed parameters, exquisitely tuned and astonishingly consistent, yet ultimately contingent upon a hidden architect, a programmer whose identity may forever remain unknowable. Equally provocative is the idea of cosmological natural selection. Some theorists suggest that universes themselves might reproduce, generating new cosmoses with slightly altered laws and constants, a kind of evolution writ large across reality. In this framework, laws are not eternal decrees, but traits subject to selection. Universes with stable, consistent rules are more likely to give rise to complex structure, stars, and life, while universes with chaotic or inhospitable laws fade into irrelevance. Law, here, is emergent, a product of a vast cosmic lottery in which only certain configurations persist long enough to be observed. The universe's obedience is thus simultaneously natural and selective, arising from deeper processes that echo the logic of evolution, where order emerges because disorder cannot sustain itself. Modern quantum research deepens this sense of wonder. Some proposals posit emergent spacetime, where the geometry of the cosmos and the laws that govern it arise from patterns of quantum entanglement. Space and time are not fundamental, but collective phenomena arising from correlations among information-rich quantum states. In this picture, the laws we observe are secondary effects, a statistical manifestation of deeper, invisible connections. Reality obeys rules because entanglement enforces consistency, as though the universe is knitting itself into coherence from countless invisible threads. The cosmos is self-organizing, obeying law not by imposition but through the natural logic of its own structure. The mathematical universe hypothesis, proposed by Max Tegmark, takes the speculation even further. In this vision, reality is mathematics itself. The universe is a structure in which laws exist simply because mathematical consistency is all that is required for existence. The rules of physics are not imposed. They are inevitable consequences of the logic inherent in the mathematical substrate of reality. Holographic principles extend this idea, suggesting that the three-dimensional world we experience may itself be a projection from deeper dimensions, a shadow in which law is an emergent property of information encoded on cosmic boundaries. Even the most exotic of these theories share a poetic truth. Law is not an external dictate, but the natural grammar of existence, the syntax of reality's unfolding narrative. Some of the most fringe ideas are almost philosophical in their subtlety. Could law itself be an illusion, a self-enforcing consistency arising from the universe's own structure? Might reality obey rules simply because consistency is a prerequisite for existence, a constraint baked into the logic of being? In such reflections, law becomes less a set of prescriptions and more the punctuation, the grammar of existence, a framework that allows phenomena to emerge, patterns to persist, and consciousness to perceive. The universe, in this view, is both obeying and inventing its own rules. A dynamic interplay of logic, structure, and possibility, revealing law as both real and astonishingly mysterious. The poetic scaffolding of reality itself, in these speculative realms, the universe becomes a mirror of possibility, where law is both real and enigmatic, tangible yet mysterious. The simulation hypothesis, while controversial, invites a profound contemplation. If the cosmos is a constructed system, then obedience is embedded at the deepest level, and the rules we perceive are constraints designed for coherence rather than necessity. Every orbit, every photon, every subatomic interaction is a line of code executed with perfection. Yet the ultimate programmer remains unseen, leaving the universe simultaneously intelligible and unfathomable. It is a vision that blends the scientific with the philosophical, suggesting that law is not merely discovered, but encoded, woven into the very scaffolding of existence in a language that transcends ordinary comprehension. Cosmological, natural selection extends this meditation on law as emergent. If universes reproduce like living organisms, then order itself may be the product of survival. Laws emerge because they permit persistence. Only universes capable of sustaining structure, stars, and complexity endure long enough to be observed. Chaos exists in the background, but it is inherently self-limiting, unable to produce observers to perceive it. In this sense, law is the residue of success, a pattern etched across generations of universes, a cosmic evolution that mirrors the elegance and randomness of life itself. The obedience of the universe becomes a story of persistence, a triumph of coherent structure over the vast potential for disorder. Quantum theories add further nuance. Emergent spacetime suggests that the familiar dimensions of space and time, and the laws they obey, may themselves arise from the entanglement of quantum states. In this vision, law is a collective phenomenon. Particles follow rules because the network of correlations enforces consistency across the cosmos. The universe self-organizes, weaving order from the threads of entanglement. And what we perceive as a mutable law is actually the manifestation of hidden, underlying patterns. Here, obedience is not imposed but arises naturally, a product of the universe's intrinsic architecture, subtle and invisible, yet profound in its consequences. The mathematical universe, hypothesis, and holographic principles further dissolve the line between law and essence. If reality is mathematics, then the laws we observe are inevitable, flowing directly from the internal consistency of existence itself. The cosmos becomes a geometric, algorithmic entity, and law is not a decree but a property of being. Holographic models suggest that three-dimensional law may itself be a projection of information encoded on higher dimensional boundaries, a shadow of deeper principles. In every case, the poetic metaphor emerges. Law is the grammar of existence, the syntax through which the universe writes itself into coherence, revealing that obedience may be intrinsic to the very act of being, even at the fringes of speculation. Law maintains its presence, whether encoded in a cosmic program, evolved across universes, emerging from entangled quantum states, or inscribed in mathematical structures. The universe demonstrates a remarkable fidelity to patterns that permit coherence, persistence, and perception. Law is simultaneously visible and hidden, contingent yet enduring, a framework that allows phenomena to exist, yet whose ultimate origin remains a profound mystery. The cosmos obeys, yet it also invents its own rules. creating a delicate balance between determinism, emergence, and possibility, a dynamic dance that continues to intrigue, inspire, and humble humanity at every step in the heart of modern physics. Humanity's instruments have become portals to the most intimate workings of reality. Particle accelerators like the Large Hadron Collider hurl protons at near-light speeds, recreating the conditions of the early universe and unveiling the subtleties of fundamental law. The discovery of the Higgs boson confirmed a mechanism that endows particles with mass, a cornerstone of the Standard Model, and yet each experiment opens new questions. Supersymmetry, hypothesized to unify known forces and resolve persistent anomalies, remains elusive, reminding us that law may be elegant, but not yet fully revealed. These machines, colossal and precise, are more than tools, they are extensions of human curiosity. Instruments that allow consciousness to probe the very scaffolding of existence, searching for the constants and symmetries that govern reality. Beyond, the microscopic, gravitational wave observatories have opened a window into the cosmic rhythm itself. When black holes collide or neutron stars spiral into each other, ripples traverse spacetime, carrying messages that confirm Einstein's predictions, while also offering hints of physics beyond general relativity. Each detection is a whisper from the universe, revealing obedience to law, yet leaving room for mystery. These waves suggest that even the most extreme events are not anarchic. They follow a cosmic choreography, a hidden order that can be deciphered if one knows where and how to listen. Yet, as telescopes and detectors reach further, anomalies emerge. Dark matter, invisible yet gravitationally potent, and dark energy, accelerating cosmic expansion, hint that the laws we observe are incomplete. Observational cosmology, empowered by instruments like the James Webb Space Telescope, maps the earliest galaxies and measures the growth of structure across billions of years. The universe obeys rules, yet the cosmos continues to surprise. Galaxies rotate as if governed by unseen mass. Cosmic acceleration defies known forces, and every discovery suggests that law may be provisional, emergent, or layered upon deeper principles yet to be understood. Computational physics offers another frontier. Supercomputers simulate universes under alternate laws, exploring what-if scenarios that probe the necessity and contingency of fundamental constants. By modeling different physical realities, scientists explore the boundaries of law, seeking to understand why our universe is coherent, and whether the obedience we observe is inevitable or contingent. These efforts blur theory and experiment, suggesting that law itself may be a pattern arising from underlying structures, tested not only in laboratories but in digital cosmoses, where every possibility can unfold. Amid these investigations, the debate persists. Are laws ultimate truths, eternal and immutable, or emergent patterns, conditional upon deeper structures and cosmological history? Physicists are divided, yet all are united in awe and inquiry. Law becomes more than a scientific tool. It is a compass guiding exploration into the unknown, a silent architect shaping the trajectory of curiosity itself. Humanity reaches ever outward, probing quarks, waves, galaxies, and even the edges of imagination, seeking the source, the scope, and the limits of the rules that the universe so faithfully, yet mysteriously, obeys. In every collision, every ripple, every photon captured, the cosmos whispers its adherence to law, reminding observers that obedience is evident, Yet its origin remains one of the most profound questions of existence. Each experimental triumph, an observational breakthrough, is a testament to humanity's persistent quest to understand the scaffolding of reality. The Large Hadron Collider, for all its monumental engineering, is more than a machine. It is a bridge between curiosity and the cosmos, a device that transforms abstract theory into measurable reality as protons collide at unimaginable speeds. They unveil the subatomic ballet that underpins existence. Particles flicker into and out of being, forces manifest in fleeting interactions, and the universe obeys with astonishing fidelity. Yet every result is a reminder of humility. Each discovery answers questions while simultaneously opening new enigmas, suggesting that law, for all its apparent precision, may be provisional, layered, or emergent from a deeper unseen structure. Gravitational waves extend this narrative across vast cosmic distances. When massive objects twist and merge, ripples propagate through space-time itself, affirming Einstein's century-old predictions and exposing the universe as a living, dynamic fabric governed by law. These signals, faint yet persistent, carry the story of cataclysmic events that occurred billions of years ago. The cosmos reveals obedience, not as a static decree, but as a dynamic symphony, a choreography of energy and geometry. In detecting and interpreting these waves, humanity participates in a dialogue with the universe itself, listening to the rhythms of creation and learning that law manifests not only in equations, but in the very pulse of existence at larger scales. Mysteries like dark matter and dark energy challenge our comprehension of law's completeness. Invisible yet influential, dark matter sculpts galaxies, while dark energy drives the accelerated expansion of the cosmos, hinting at layers of reality that defy current understanding. Observatories like the James Webb Space Telescope peer deep into space and time, capturing light that has traveled for billions of years. These observations reveal a cosmos that is both orderly and enigmatic, following recognizable patterns, yet presenting anomalies that suggest law is not a finished story, but a tapestry woven of known rules and hidden forces. Humanity is confronted with obedience that is evident but incomplete, a harmony that hints at deeper, uncharted dimensions. Computational physics now allows scientists to simulate entire universes under alternative sets of laws. These digital experiments explore the boundaries of possibility, revealing how small changes in constants or interactions can yield radically different realities. Through this lens, law is not only observed, but interrogated, tested, and imagined. Simulations demonstrate that the patterns we take for granted are fragile yet resilient, emergent from complex interactions rather than imposed externally. Law, it seems, is both a guide and a consequence, a structure that allows the cosmos to persist while remaining subject to subtle contingencies. Amid these efforts, physicists grapple with profound philosophical questions. Are laws ultimate, eternal truths, or patterns emergent from deeper, unseen frameworks? Are constants fixed by necessity, or selected by the interplay of cosmic evolution and stability? Even as science advances, law retains a dual nature. It is at once empirical and mysterious, measurable and ineffable. Humanity's exploration is an act of both intellect and reverence, guided by the recognition that the universe obeys rules with astonishing fidelity, yet that the source, origin, and ultimate scope of those rules may forever remain a profound and poetic mystery. In every measurement, every collision, every captured photon, the cosmos whispers a silent testament, it follows law. And through that obedience, it invites us to ponder the sublime enigma of existence itself. Stars ignite and burn, planets orbit with unwavering precision, and subatomic particles follow paths dictated by equations written in the language of mathematics. Yet the universe did not need to be orderly. Chaos could have reigned unchecked. Matter could have scattered into entropy without pattern. Galaxies could have collided without rhythm, and life might never have emerged. The obedience of the cosmos carries a weight that is almost existential, suggesting that law is not a mere convenience of perception, but a fundamental scaffold on which reality itself rests. It is a mystery that inspires awe, inviting the mind to dwell not only on what is observed, but on what could have been, on the vast range of unrealized possibilities where law did not hold. Humanity instinctively compares cosmic order to the fragile architectures of its own making. Societies without laws collapse into disorder. Rules, whether written or unwritten, are the scaffolding of civilization. Do we see the universe as ordered because it mirrors our sense of structure? Or do our structures reflect the deep, unyielding obedience of reality? Perhaps the universe itself is not conscious of its laws, yet it exhibits a fidelity to principle that mirrors our own need for order, a resonance between human perception and cosmic consistency. In contemplating this, the mind is drawn to the tension between freedom and structure. Laws allow patterns to emerge, complexity to flourish, and life to exist, but they also impose a kind of cosmic cage, a boundary to what is possible, a reminder that even imagination is tethered to the contours of reality. The mystery deepens when one considers the nature of necessity versus chance. Are the laws of physics eternal truths etched into existence before time itself, as immutable as geometry? Or are they the contingent product of a universe that might easily have behaved differently, a coincidence that permits stability, complexity, and consciousness to arise? The question touches on the edge of philosophy and spirituality alike. Some see in the cosmos a reflection of divine order, an underlying intelligence that has set rules with purpose and foresight. Others perceive impersonal mathematics, a universe bound not by will but by intrinsic logic, obeying consistency because inconsistency cannot persist. Law becomes simultaneously comforting and unsettling structure that ensures stability yet reminds us of our own limitations. The tension between the predictability we rely upon and the freedom we yearn for. Perhaps, in the end, law is not merely inscribed on the universe, but on human minds interpreting it. Our cognition seeks patterns, draws lines through chaos, and perceives rules in the flickering dance of particles and galaxies. The obedience we witness may be as much a reflection of consciousness as it is of reality itself, a dialogue between existence and perception, a mirror held up to the cosmos by those who seek to understand it. And yet, even if law emerges from observation, the question persists with breathtaking gravity. If the universe must obey laws, who or what enforces them? In the silence between stars, in the rhythm of celestial motion, and in the fleeting pulse of life, the answer remains elusive. A final mystery suspended at the heart of reality, inviting wonder, reflection, and the eternal pursuit of understanding. The universe's obedience to law is not merely a scientific curiosity. It is a mirror to the human condition, a reflection of the ways in which structure and freedom intertwine. Just as societies rely on rules to maintain cohesion, the cosmos relies on constants, symmetries, and principles to persist. Yet, unlike human laws, cosmic rules do not bend to desire or convention. They are impartial, indifferent, and at times almost cruel in their precision. A star explodes, a planet is torn apart by gravity, yet the underlying order remains intact. This impartiality reminds humanity that law is neither punishment nor reward, but the invisible architecture that shapes possibility itself. There is comfort in this order, a sense that chaos is bounded, that existence has a rhythm that can be studied, measured, and, to some degree, anticipated. And yet, this comfort carries its own subtle tension, knowing that the universe is so. Obedient can feel constraining, a reminder that imagination, creativity, and freedom are always bounded by the laws that govern reality. The philosophical weight deepens when one considers the mystery of necessity versus contingency. Do these laws exist because they must, etched into the fabric of existence with inevitability, or are they the result of chance, emerging from a cosmos that could easily have been otherwise? The anthropic principle offers one perspective. The universe appears orderly because only in an orderly universe could observers arise to notice it. Life, consciousness, and reflection themselves may be the natural consequence of law. And yet this does not answer the question of origin. There is an almost spiritual undertone here, a sense that law is both a gift and a constraint. Some traditions see it as divine orchestration, a grand intelligence guiding the unfolding of reality. Others see it as the pure mathematics of existence, impersonal and self-consistent, obeyed because inconsistency cannot sustain a coherent universe. Either way, the obedience of the cosmos evokes awe, humility, and a quiet reverence. A recognition that law is not simply a human construct, but a principle that underpins all being. Perhaps, in the end, laws are not only in the universe, but in the act of observation itself. Humanity interprets, measures, and codifies patterns, transforming observation into understanding, and understanding into narrative. In this sense, the law is a bridge between reality and consciousness, a lens through which the cosmos becomes intelligible, yet the ultimate enforcer, the source of this obedience, remains a mystery. Whether written into the fabric of space-time, emerging from deeper structures, or encoded in the logic of mathematics itself, the question lingers with poetic gravity. If the universe must obey laws, who or what ensures that they are followed? It is a question that transcends science, touching philosophy, spirituality, and the deepest currents of human wonder. In the silent expanse between stars, in the subtle alignment of galaxies, and in the invisible choreography of subatomic particles, the universe whispers its fidelity to law. It is a quiet testament, an eternal performance whose audience is consciousness itself, a story of order emerging from the void, of structure arising from potential chaos. And yet, even as humanity deciphers its rules, experiments with its constants, and contemplates its origin, the ultimate source of obedience remains veiled. Law is both evident and enigmatic, a compass guiding exploration, a framework nurturing life, and a mystery that inspires reflection across generations. In the end, the universe obeys, and in its obedience, the universe's adherence to law is at once comforting and unnerving, a paradox that has haunted thinkers from Newton to Hawking. There is beauty in consistency, the way planets trace precise arcs through the void, the predictable cycles of stars, the rhythmic pulse of cosmic phenomena, but beneath that beauty lies an unsettling question. Is this order necessary, or merely coincidental? Laws of physics do not negotiate, they do not waver. and yet they allow the emergence of complexity, consciousness, and imagination. Humanity sees in this obedience both a guide and a challenge, a reminder that while patterns can be discerned and principles applied, the source of law may lie forever beyond comprehension. It is as if the cosmos presents a silent performance, each interaction, each trajectory meticulously choreographed, yet without an audience to dictate its design. Human experience inevitably frames the contemplation of cosmic law. Just as societies collapse in the absence of governance, we perceive the universe through the lens of order and structure, extrapolating stability from the predictable to the sublime. There is a tension here. Humans are pattern-seeking creatures, finding meaning and security in law, yet this very order can feel confining. Laws enable possibility, they allow stars to burn long enough for planets to form, life to emerge, civilizations to rise, but they also impose limits. In obeying laws, the universe demonstrates freedom within constraints. Particles, planets, galaxies move according to principles that are strict, yet within those bounds, creativity and complexity flourish. The obedience of the cosmos is simultaneously liberating and binding, a duality mirrored in the human condition. Philosophical and spiritual reflections deepen this mystery. Some see law as divine, a manifestation of intelligence woven into the very fabric of existence, a cosmic script written with purpose. Others see it as impersonal, the inevitable consequence of mathematics and logic, where obedience arises because inconsistency cannot endure. Both perspectives converge on a profound realization, whether by design or necessity, the universe exhibits fidelity to principles that enable coherence, structure, and life. Law, in this sense, becomes not only a scientific concept, but a bridge between reality and meaning, a silent testament to the harmony that allows existence itself. Perhaps the ultimate truth is that laws are both external and internal. They are embedded in the cosmos, yet interpreted, codified, and understood through the human mind. Observation, measurement, and reflection transformed the raw obedience of nature into knowledge, and knowledge into wonder. Humanity stands at the intersection of perception and reality, recognizing that the universe follows rules, yet questioning the origin of that fidelity. If the universe must obey laws, who or what enforces them? In this question lies the ultimate cinematic tension, an unanswerable mystery that drives inquiry, inspires awe, and unites science, philosophy, and imagination in the contemplation of existence itself. The obedience of the cosmos is a mirror, in which humanity glimpses both its aspirations and its limitations. As we trace the arcs of planets, chart the collisions of galaxies, and measure the trembling of space-time itself, we confront an immutable truth. The universe is ruled by patterns that are precise, consistent, and unyielding. Yet this precision raises a haunting question: does the universe follow law because it must, or because it has chosen, in some sense, to be coherent? Unlike human institutions, which bend and fracture under pressure, cosmic law appears absolute. There is no negotiation, no appeal, no exception. And still, in its unwavering fidelity, it allows the emergence of life, consciousness, and imagination. The paradox is sublime. Law is both liberating and constraining, the invisible architecture that makes existence possible while simultaneously imposing boundaries on what can be. Humanity's own experience with order informs this contemplation. Just as societies without law crumble into chaos, we perceive stability as both a gift and a necessity. We instinctively recognize that structure permits creativity, that rules enable exploration, and yet we feel the subtle tension of confinement. In obeying laws, the universe demonstrates consistency, yet in doing so it imposes limits. It is a dance between freedom and structure, a cosmic choreography in which particles, planets, and galaxies move with fidelity to principles we strive to understand. Our minds, attuned to patterns, seek to grasp the invisible threads that bind reality, translating cosmic obedience into meaning. Yet the ultimate source of that fidelity remains shrouded in mystery. The philosophical weight of cosmic law extends beyond empirical observation into the realms of contemplation and wonder. Are laws divine edicts set by an intelligence beyond comprehension? Or are they emergent properties arising naturally from the logical structure of existence, inevitable consequences of mathematics and symmetry? The tension between necessity and contingency remains unresolved. Some suggest that laws exist because, without them, complexity, life, and consciousness could not emerge a reflection of the anthropic principle. Others see law as a fundamental substrate of reality, intrinsic and eternal. Either interpretation conveys the same sense of awe. The universe is ordered, comprehensible to a degree, yet infinitely mysterious, a paradox that invites both scientific inquiry and philosophical reflection. Perhaps, ultimately, law resides not solely in the cosmos, but also in the act of perception itself. Humanity interprets, measures, codifies, and reflects, transforming the silent obedience of reality into knowledge, narrative, and contemplation. Our understanding of law becomes a dialogue between mind and universe, a bridge that connects the finite with the infinite. In this interplay lies a profound tension, a poetic truth. The universe follows rules, yet the enforcer of these rules remains unknown. In the quiet of interstellar space, in the steady rhythm of celestial mechanics, and in the invisible pulses of quantum phenomena, the cosmos presents a final, cinematic question. If reality must obey law, who or what ensures its fidelity? It is a question without a definitive answer, a mystery that drives exploration, fuels wonder, and illuminates the eternal pursuit of understanding at the heart of science, philosophy, and human imagination. In contemplating the obedience of the cosmos, one cannot help but sense a quiet dialogue between existence and awareness. Stars trace their orbits, galaxies spiral in majestic arcs, and particles dance according to laws that have governed reality since the first instance of the Big Bang. Yet, in observing this fidelity, humanity confronts a tension between reverence and curiosity, between awe and the insatiable desire to know. The universe is precise, consistent, and astonishingly resilient. Yet every discovery reminds us that our understanding is partial, that each law we uncover may be a glimpse of a deeper hidden order, or merely an emergent pattern arising from structures we have yet to perceive. This duality is the essence of the human experience of law. It is at once a compass, guiding exploration and comprehension, and a veil, hinting at truths forever beyond our grasp. Human metaphor extends naturally into philosophical reflection. Societies without rules collapse, unable to maintain cohesion, yet the universe operates on a scale that far exceeds human comprehension. Is our perception of law imposed by our minds, a projection of our need for predictability, or does the cosmos possess a fidelity that is independent of observation? Perhaps law is both, embedded in the structure of reality, yet interpreted and codified by conscious observers who seek patterns and meaning in the void. The obedience we witness may be a mirror, reflecting our own yearning for order, a resonance between the architecture of existence and the architecture of thought. In this, there is both comfort and a subtle unease. Law makes life possible, but it also imposes boundaries, subtle constraints within which creativity, imagination, and freedom must navigate. The mystery of law extends beyond science into the spiritual and existential. Some see in cosmic obedience a reflection of divine intelligence, an intentional design that ensures coherence and stability. Others perceive a purer, impersonal truth, that law emerges inevitably from the logic and mathematics underlying reality, not as a decree, but as the necessary consequence of structure itself. In either interpretation, law becomes a bridge connecting the empirical and the transcendent, a principle that governs matter and energy, yet inspires wonder, reflection, and philosophical inquiry. The universe's fidelity is a story told not only in equations and observations, but in the emotional resonance of comprehension, a narrative that evokes humility and awe in equal measure. Perhaps, ultimately, the laws of the universe are inseparable from the act of human perception. To observe, measure, and interpret is to participate in a dialogue with reality itself, to translate the silent obedience of the cosmos into knowledge, insight, and narrative. Law exists both in the cosmos and in the mind, a dual manifestation that shapes understanding and imagination. And yet, the ultimate question lingers in the spaces between stars, in the rhythm of galaxies, and in the flicker of quarks. If the universe must obey laws, who or what ensures their fidelity? It is a question that transcends the boundaries of physics, entering the realms of philosophy, spirituality, and wonder. It is a question without resolution, yet it compels exploration, inspires contemplation, and illuminates the eternal tension between mystery and understanding, between the finite human mind and the infinite cosmos it seeks to comprehend. The universe's fidelity to law speaks to a tension at the heart of human consciousness, the simultaneous desire for understanding and the acceptance of mystery. Every observation, from the smallest particle interaction to the grand dance of galaxies, reinforces a sense of order, yet also hints at deeper layers of unknown principles. Time, space, and energy all adhere to patterns we can measure, predict, and manipulate. Yet their origin, their necessity, and their ultimate source remain elusive. This obedience is both a revelation and a challenge. It offers a framework for knowledge, a scaffolding that allows science to flourish, yet it resists finality. The cosmos communicates not in words, but in the language of low equations, constants, symmetries, and those who listen are left with the poetic tension of clarity and enigma entwined. Humanity naturally interprets this cosmic obedience through metaphor and analogy, reflecting on our own need for rules, for governance, for structure. Just as societies collapse without laws, so too does the mind seek patterns in the flux of perception. The cosmos mirrors this necessity, presenting order where chaos could just as easily have prevailed. Yet this reflection is imperfect. Unlike societies, the universe does not deliberate, it does not intend. Its obedience is neither moral nor conscious, and yet it provides a stage upon which complexity, life, and consciousness can emerge. The laws that govern reality are simultaneously liberating and constraining. They allow stars to shine, planets to orbit, and minds to contemplate. yet they define the bounds of possibility, establishing the contours within which imagination must operate. The philosophical weight of these observations cannot be overstated. Are laws eternal, absolute, unnecessary, or are they contingent, emergent, a reflection of deeper structures we have yet to perceive? Some see in cosmic law the signature of a guiding intelligence, a reflection of purposeful design. Others see it as impersonal, a consequence of mathematical consistency and logical necessity. In either view, law forms the invisible architecture of reality, shaping the cosmos and shaping the human capacity for understanding. It is a source of comfort and awe, yet also a reminder of our limitations. The universe is obedient, but that obedience is inscrutable, leaving room for wonder, humility, and reflection. Perhaps law exists as much in perception as in reality. Observation and consciousness translate the cosmos' silent fidelity into meaning, allowing humanity to engage with the principles that govern existence. Through measurement, thought, and contemplation, humans participate in a dialogue with reality itself, bridging the gap between comprehension and mystery. And yet, even as we measure, simulate, and theorize, the ultimate enforcer of these cosmic rules remains unseen. In the flicker of distant starlight, the arcs of galaxies, and the subatomic dance of particles, the universe hints at an unseen hand or perhaps an inherent logic that ensures obedience. It is the final question, the ultimate cinematic tension. If the universe must obey laws, who or what upholds them? In this unanswerable question lies the profound beauty of existence, a mystery that drives inquiry, inspires awe, and binds science, philosophy, and imagination together in the contemplation of reality itself.